temperature rating of a circuit breaker indicates the maximum temperature the breaker can withstand while carrying its rated current. Similarly, a wire's temperature rating signifies its maximum safe operating temperature while conducting its rated current. As a general rule, a circuit breaker should have a temperature rating equal to or higher than the wire it protects. This design ensures the breaker can effectively safeguard the wire against overheating. However, there are exceptions. A higher rated circuit breaker can be used with a low rated wire, but only if the breaker's current carrying capacity is appropriately reduced or derated. Looking at Square D Homeline breakers, the 40 amp and higher 2-pole breakers are rated for 75 degrees Celsius, while the 30 amp and lower breakers have a 60/75 degrees Celsius rating. This means the larger breakers necessitate wire rated for at least 75 degrees Celsius, whereas the smaller ones can use either 60 degrees Celsius or 75 degrees Celsius wire. The difference stems from the current handling capacity. The 40 amp and higher breakers are designed for larger currents. They require higher temperature rated wire to prevent overheating under heavy loads. Always follow the manufacturer's installation instructions for circuit breakers. If unsure about temperature ratings or wire compatibility, consult a qualified electrician. This ensures safety and code compliance. Understanding these ratings is crucial for safe and effective electrical installations. Now let us delve into some more details regarding wire and breaker selection. When selecting wire for a specific application, several factors must be considered beyond just the temperature rating. These include the ampacity of the wire, which is the maximum current it can safely carry, the voltage drop over the length of the wire, and the environmental conditions in which the wire will be installed, such as temperature and moisture levels. The National Electrical Code, or NEC, provides detailed guidelines for wire selection based on these factors. Article 310.15 and related tables within the NEC are particularly important for determining the appropriate wire size and type for a given application. These tables specify the ampacity of various wire types based on their insulation material, size, and installation method. It is crucial to consult these tables to ensure that the wire selected is capable of safely carrying the intended load. Voltage drop is another critical consideration, especially for long wire runs. Voltage drop occurs when the voltage at the load end of the wire is lower than the voltage at the source end due to the resistance of the wire. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, larger wire sizes may be required, even if the ampacity of the smaller wire would be sufficient. Environmental conditions also play a significant role in wire selection. Wires installed in hot or wet locations must be specifically rated for those conditions. For example, THHN wire is commonly used in dry locations, while THWM wire is suitable for wet locations. The insulation material of the wire must be able to withstand the expected temperature and moisture levels without degrading or becoming a safety hazard. In addition to wire selection, it is also important to properly terminate the wire of both the circuit breaker and the load. Proper termination techniques ensure a secure and reliable connection, minimizing the risk of overheating or arcing. Use appropriately sized connectors and torque them to the manufacturer's specifications. Now let's discuss the selection of circuit breakers in more detail. Circuit breakers are designed to protect electrical circuits from overcurrents, which can be caused by short circuits, overloads, or ground faults. When an overcurrent occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to the wiring and equipment. Circuit breakers are rated in amps, which indicates the maximum current they can carry without tripping. It is important to select a circuit breaker with an amp rating that is appropriate for the circuit it is protecting. The NEC specifies the maximum allowable overcurrent protection for various types of circuits. For example, a 15 amp circuit typically requires a 15 amp circuit breaker, while a 20 amp circuit requires a 20 amp circuit breaker. However, there are some exceptions to this rule. For example, motor circuits may require larger circuit breakers to accommodate the inrush current that occurs when the motor starts. The interrupting rating of a circuit breaker is another important consideration. The interrupting rating is the maximum fault current that the circuit breaker can safely interrupt without failing. Circuit breakers used in residential applications typically have an interrupting rating of 10,000 amps, while circuit breakers used in commercial and industrial applications may have interrupting ratings of 25,000 amps or higher. It is important to select a circuit breaker with an interrupting rating that is sufficient for the potential fault current to the installation location. Circuit breakers are available in a variety of types, including thermal, magnetic, electronic, and solid state. Thermal-magnetic circuit breakers are the most common type in use. A bimetallic strip and an electromagnet to detect overcurrents. Electronic circuit breakers use electronic circuitry to detect overcurrents and offer more precise and adjustable tripping characteristics. Solid-state circuit breakers use solid-state components to detect overcurrents and offer even faster and more reliable protection. When installing circuit breakers, it is important to follow the manufacturer's instructions and the requirements of the NEC. Circuit breakers must be properly mounted in an approved enclosure and connected to the electrical system using appropriately sized conductors. The connections must be tight and secure to prevent overheating and arcing. It is also important to label each circuit breaker with its corresponding circuit number and the loads it served. This makes it easier to identify and troubleshoot circuits in the future. In addition to selecting the correct wire and circuit breaker, it is also important to consider the overall design of the electrical system. The electrical system should be designed to provide adequate power to all of the loads while minimizing voltage drop and ensuring safety. The NEC provides detailed guidelines for designing electrical systems, including requirements for grounding, bonding, and overcurrent protection. Grounding is the process of connecting the electrical system to the earth, which provides a path for fault current to flow back to the source. Grounding helps to prevent electrical shock and reduce the risk of fire. Bonding is the process of connecting all of the metal parts of the electrical system together, which creates a low impedance path for fault current. Bonding helps to ensure that all metal parts are at the same potential, which reduces the risk of electrical shock. Overcurrent protection is the use of circuit breakers or fuses to protect electrical circuits from overcurrents. Overcurrent protection is essential for preventing damage to wiring and equipment and reducing the risk of fire. Now let's discuss some common electrical problems and how to troubleshoot them. One of the most common electrical problems is a tripped circuit breaker. A circuit breaker can trip due to an overload, a short circuit, or a ground fault. To troubleshoot a tripped circuit breaker, first identify the circuit that is affected. Then unplug any appliances or equipment that are connected to that circuit. Reset the circuit breaker. If the circuit breaker trips again immediately, there is likely a short circuit or a ground fault. If the circuit breaker stays on, gradually plug in the appliances and equipment one at a time until the circuit breaker trips again. This will help to identify the source of the overload. Another common electrical problem is a flickering light. A flickering light can be caused by a loose connection, a faulty switch, or a problem with the wiring. To troubleshoot a flickering light, first check the bulb to make sure it is properly installed. Then check the switch to make sure it is functioning properly. If the problem persists, there may be a loose connection in the wiring. A qualified electrician should be called to inspect and repair the wiring. Electrical outlets can also fail to work. An outlet may not work due to a tripped circuit breaker, a loose connection, or a faulty outlet. To troubleshoot a non-working outlet, first check the circuit breaker to make sure it is not tripped. Then check the outlet for loose connections. If the outlet is still not working, it may be faulty and need to be replaced. When working with electricity, it is important to take precautions to avoid electrical shock. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear rubber gloves to protect yourself from electrical shock. Never work on electrical equipment in wet conditions. If you are not comfortable working with electricity, call a qualified electrician. Now let's consider specific examples related to the Square D Homeline breakers. If you are using a 40 amp Square D Homeline breaker, you must use wire that is rated for at least 75 degrees Celsius. Common wire types that meet this requirement include THHN, THHW, and XHHW. If you are using a 30 amp Square D Homeline breaker, you can use wire that is rated for either 60 degrees Celsius or 75 degrees Celsius. Common wire types that meet this requirement include NMB, THHN, THHW, and XHHW. It is important to note that the ampacity of the wire must be appropriate for the circuit breaker. For example, a 12 American wire gauge copper wire rated for 75 degrees Celsius has an ampacity of 25 amps, which is suitable for a 20 amp circuit breaker. A 10 American wire gauge copper wire rated for 75 degrees Celsius has an ampacity of 30 amps, which is suitable for a 30 amp circuit breaker. When installing circuit breakers, it is important to follow the manufacturer's instructions and the requirements of the NEC. The circuit breaker must be properly mounted in an approved enclosure and connected to the electrical system using appropriately sized conductors. The connections must be tight and secure to prevent overheating and arcing. It is also important to label each circuit breaker with its corresponding circuit number and the loads it serves. This makes it easier to identify and troubleshoot circuits in the future. In summary, selecting the correct wire and circuit breaker is essential for ensuring the safety and reliability of an electrical system. It is important to consider the temperature rating of the wire and circuit breaker, the ampacity of the wire, the voltage drop over the length of the wire, and the environmental conditions in which the wire will be installed. Always follow the manufacturer's instructions and the requirements of the NEC when installing electrical equipment. If you are not comfortable working with electricity, call a qualified electrician. Furthermore, understanding the nuances of conductor ampacity and the allowable ampacities based on terminal temperature limitations is very important. Most breakers and equipment in residential and commercial settings are rated for 75 degrees Celsius terminals. This means that even if you are using wire with a 90 degrees Celsius insulation rating, you must use the 75 degrees Celsius ampacity column in NEC Table 310.15. B16 unless the equipment is specifically listed and labeled for use with 90 degrees Celsius conductors. This is a common point of confusion, but it is critical for ensuring safe operation and compliance with electrical codes. In addition, remember to account for any ambient temperature corrections or adjustments for multiple conductors in a raceway, as these can further reduce the allowable ampacity of the conductors. The NEC provides detailed guidelines for these adjustments, which must be followed to prevent overheating and potential fire hazards. Ground fault circuit interrupters, or GFCIs, are also important safety devices that should be installed in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect even small amounts of current leakage to ground and quickly interrupt the circuit, preventing serious injury or death. Arc fault circuit interrupters, RFCIs, are another type of safety device that is designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. SIs are now required in many areas of the home, particularly in bedrooms and living areas, to provide added protection against electrical fires. Regular inspection and testing of electrical systems is also important for ensuring continued safety and reliability. It is recommended to have a qualified electrician inspect your electrical system at least every 3 to 5 years to identify any potential problems and make necessary repairs. During an inspection, the electrician will check for loose connections, damaged wiring, and other potential hazards. They will also test the operation of GFCIs and FCIs to ensure that they are functioning properly. By following these guidelines and working with a qualified electrician, you can help to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember that electricity can be dangerous, and it is always best to err on the side of caution when working with electrical equipment. If you are unsure about anything, consult with a qualified electrician before proceeding.